Hello everyone, my name is Saurabh Pant and I'm continuing with my Rank Booster series. Nowadays I'm getting a lot of doubts in thermodynamics. Maybe you are revising thermodynamics nowadays too much, that's why. So I have not uploaded, not even a single video is there on my channel regarding the thermodynamics. So I'm starting the thermodynamics part not from the basic, like what is the system surrounding extensive intensive properties. Even though those who are my students, they will understand very well that many good questions can be made from there also. But I don't think that is much relevant for those people who are still struggling to solve basic numericals in the thermodynamics at this point of time. So it's better we will focus upon the more marks scoring topics. For that, you need to understand how to find the work done, internal energy change and heat transfer. For these things, the most basic thing that a student ignore is reversible and irreversible process. Before teaching you reversible, irreversible process today, as you would have seen in the link name also, the process name is very clearly mentioned, but topic name is also mentioned. Why I'm discussing this topic? Majorly for the work done in the isothermal process, if you have seen the formula, minus 2.303 nRT log V2 by V1 or P1 by P2 is the reversible work done for isothermal process. For irreversible isothermal, we have minus P external V2 minus V1. Now, which formula you will apply out of these two does not depend upon the information given in the form of numerical values, but it depends upon the conditions given. Sometimes the paper setter will mention reversible, irreversible very easily. But sometimes the paper setter might play with your mind and will give you the conditions, and if you know how the reversible, irreversible concepts are decided, then only you will be able to apply the correct formula. So let us make you prepared for it. What is a reversible process? A process which can be reversed at any instant by bringing about a small change. If you bring about a small change, and the process can be immediately reversed in the opposite direction, that kind of process is called reversible process. Let's take one example. If I move in this room in forward direction and at any point of time I can come back. So is my movement reversible or not? Like I go forward and anytime I want I can come back. So is my movement reversible or not reversible? So if your answer is yes sir, reversible, yeah, you were going forward and then you came back, you reversed very easily. Answer is no. In thermodynamics we talk about energy. When I went forward, I released energy. I used my own energy in walking forward. I used my own energy in coming back. So my body became tired. I am losing my energy. I'm not gaining it. So the process is not reversed. Okay, my physical path got reversed, but thermodynamically, I have not lost the energy in one direction and gained the energy in the other direction. So understand, reversibility when we say, a reversal of the process when we say, it does not mean that the same path is followed back. Physically, it means thermodynamically the same path is followed. So what is this thermodynamically the same path is followed? Whatever the energy losses you had in going forward, same energy gain you should have in coming back, or vice versa. Whatever you gained while going forward, you will lose while coming back. So bhaiya, that kind of processes which can be reversed at any point of time, and this is what the meaning reversal means, coming back in exactly in the same way. In that case, we call it a reversible process. Let's take one example. We take one ideal gas in a cylinder. This is the massless, frictionless, movable piston. On this I put one brick of mass M. Let us say the pressure exerted by the brick is P1. So right now on the ideal gas, how much pressure is exerted? It is exerted equal to P1 plus ATM. Atmospheric pressure is also there, na? So atmosphere is exerting its own pressure. Brick is exerting its own pressure. That much pressure is on the ideal gas in the initial condition. Now think about it. There is a piston. One container is there. For example, this is the container. For example, this is the container. And here is a piston. Let's say it's a massless, frictionless, movable piston. So one brick is kept over it. So let's say I put a brick over here. So the piston is not moving. That means internal pressure, external pressure is equal. No one is more. If no one is more, the brick got moved automatically. If no one is more, in that case, the piston will not move. Neither the internal is more nor the external is more. Now, if I remove this brick, I think this much you can imagine very easily. If I remove the brick, the piston will go up. That means the gas will expand now, because it's like I was sitting on the piston. It wanted to expand, but I was not letting it to expand. As soon as I got removed, but the piston will start moving up. The gas will start expanding. So what will happen? The gas will expand and little bit popping will happen. Understand this thing from the thermodynamics point of view. What happened? There was a gas, there are gas molecules inside. On the top, piston plus brick was there. So the force that these gases were applying, or the pressure these gases were applying, was equal to the external pressure. So no movement was there. After removal of the brick, outside pressure decreased by P1. P1 removed. Only 1 atm pressure left. So the gas are able to push this piston up now because their pressure is more now in this condition. Why more? Did I increase the pressure of the gas? No. I just decreased the external pressure. So what will happen? The piston will go up. So the gas is doing some work. This gas, this marker is the gas, is pushing the piston up, and here some work is done. Okay? So the gas did some work. And if gas is doing some work, that means it is releasing energy. So I will say the work done will be negative. So work done in this situation when the gas is pushing the piston up is negative. 1. Second, in case, is this reversible or not? Think about it. The brick I removed. If I try to put the brick back, what will happen? If I try to put the brick back, the pressure will increase on the top and the gas will get compressed again. So this time, outside work, from outside the work is done. That means the surrounding, the brick is pushing the gas inside. So the work is done on the system. So when I remove the brick, work done is negative. When I put the brick back, work done is positive. Or I can say that the energy, or I can say while expanding the energy was lost. But while contracting, the surrounding is pushing the gas inside. So the work is done by the surrounding. So the energy content of the gas will increase. So can I now say that this process is reversible? I remove the brick, goes up, work done by the gas. I put the brick, comes down, work done on the gas. Sir, this time to properly 100%, sir, we are confident that the work is done in opposite directions when the two processes we are considering. So this must be a reversible work done. Answer is, this is also irreversible. Why, sir? Why it is irreversible? Very simple. The work done, bilkul sahi baat hai, is by the gas when the expansion was going on, and work was done on the gas when the compression is going on. Correct. But they were not equal. Why they were not equal? Think about it now. So imagine in this way, ki let's say this is a piston. Let's say it's a piston. One container, imagine one container, this is one container here, and this is the piston on the top of it. It's movable piston, okay? On this, I keep a brick, okay? And let's say this, my hand is the ideal gas. So if I remove the brick, the gas pushed the piston up. So I pushed how much pressure? To understand, this P1 pressure is removed already. So I am not pushing that P1. I am just pushing the 1 atm pressure, the atmospheric pressure. So while expanding, I was doing the work against 1 atm. While expanding, I was doing the work against 1 atm. That means when this brick is removed, the situation will become like this, ki bhaiya, the brick goes out and now only 1 atm pressure is left from the initial condition. Now the gas start expanding, pushing this piston up. So gas does some work. This gas is pushing the piston up. So doing some work, and this work is done. This work is done against 1 atm. है ना भाई? क्यों भैया? Clear ना? Now, if I put the brick back, let's say here my brick is kept in the separate place. I put the brick back, what will happen? If I put the brick back in a way to go back to the previous condition, what would happen? Let us think. So if I put the brick back, the situation will be something like this. On this piston, I put the brick. So the pressure on this piston now, or on this gas now, is P1 plus atm. That means atmospheric pressure is there already, plus one extra pressure P1K. So when the compression is done, now this will start pushing the gas back. This will start pushing the gas back. We are going backwards now. So bhaiya, when the gas is getting pushed, it is getting pushed by, or the work is done by P1 plus atm. So understand, while going up, it was done against 1 atm, the work was done against 1 atm, but while coming back, the work is done by P1 plus 1 atm. Are you able to understand this idea? That the work is done against 1 atm, and here the work is done by P1 plus atm. So certainly this work done is more in magnitude than this work done. Na yaar? Sir, how? Very simple concept hai yaar. Very simple concept. P is minus P delta V. Sorry, W is minus P delta V. So if delta V I takes same, that means we went from V initial to V final here, and while coming back from Vf to Vi or V1 V2 I take V1 V2. So we went from V1 to V2. From V1 to V2 while expanding, and while compressing we came from V2 to V1. So delta V same. So if the P is more, then the W will also be more. That means if the work is done against 1 atm, that work is lesser, and when the work is done against work is done by P1 plus atm, then the work is more. ठीक है भाई साहब? That means in this situation the work done during expansion, this work is lesser than, in magnitude is lesser than the work done during compression. So will I call it a reversible process? The answer is no, I cannot call this a reversible process. I am going to prove this in front of you using a graph, and you will brilliantly understand this idea, and then you will understand how to use this knowledge in your examination. So I put P versus V graph, and let's say we are starting from here. Let's say the pressure in the beginning, in the initial part, the pressure is P1 plus 1 atm. P1 plus 1 atm. Let's say the volume at this point is Vi. So this is the point I'm talking about. So from here is the starting point, initial point, where the volume is Vi, pressure is P1 plus atm. So what I did remove the brick. So if I remove the brick, what will happen? External pressure will decrease to 1 atm. So right now the external pressure is P1 plus 1 atm. Now suddenly the pressure will become just 1 atm. Understand the idea? What will happen? Understand this. If for example you were walking, you fell down and your knees got hurt. So falling down is the action, and hurting of the knees is a reaction to that action, is a consequence to that action. So here if I remove the brick, this is my action. That means I decrease the external pressure, that is my action, and because of the decrease in the external pressure, the gas start expanding, that is the consequence. So always the action happens first, followed by the consequence. So what will happen? Right, for example, right now you will read and you will get selected. So selection is the consequence of your preparation right now. If you are seeing this video right now, that means you are doing the action, and this will result into a good consequence. So dekhiye bhai, so firstly what happened? When I removed the brick, I came from position I to position 1. That means the pressure suddenly dropped to 1 atm. Because of this, the volume increased to Vf, to the final volume Vf. ठीक है भाई साहब? So from Vi to Vf, you have come in this way. This is how we have traveled. So can I see like this dotted line I can plot to show you? This dotted line has no meaning. That is just, and this dot number 1 also has no meaning. This is just to show you ki how we came. Now, if I put the brick back, to understand, putting the brick back and increasing the pressure is the action. Because of that increased pressure, the compression happened, the volume get decreased of the gas, the brick will push the gas inside is the consequence. So when I want to go back, so this way I came in this direction, this way I came from initial to final, I want to go from final to initial back, so firstly I will have to put the brick. So if I put the brick back, brilliance is that bhai, pressure will increase first na. Pressure will increase, and because of the increased external pressure, the volume decreases. Chamka bhaiya. So this is the external pressure we are plotting against the volume. ठीक है भाई? So external pressure was 1 atm. When I put the brick, it becomes 1 atm plus P1, and then the gas compressed. So you can understand कि while going forward, this was the path you took in a way we can say, and while going backward, this was the path you took, and clearly these two paths are not same. In fact, if you find the area under the curve, then this is the area under the curve for expansion, and this red color is the area under the curve for compression. So we can understand area under the curve for compression is much more than the area under the curve for expansion. So we can understand this process, this specific process is a irreversible process, and this process is not reversible at all. Chamka bhaiya up to here. Now, if in the examination question will come, then how to identify? Dekho, listen carefully. Number 1, if there is a sudden change in pressure, if there is a sudden change in pressure, or expansion is done against constant pressure, then bhaiya, you have to apply irreversible formula. You can understand these two things from here. Number one, when I remove the brick, the pressure suddenly dropped from P1 plus 1 atm to 1 atm. All of a sudden, this whole brick mass got removed. All of a sudden, a whole pressure got removed. So, sudden change in pressure, sharp increase in pressure, sudden increase in pressure, sudden decrease in pressure, sharp decrease in pressure comes in the question. 100% bhaiya, you will apply irreversible. Number two, if I removed the brick, the gas expanded against 1 atm. The pressure was not changing again and again and again. One time you remove the brick, after that the whole expansion occurred against 1 atm only. So understand bhaiya ki expansion against a constant pressure, that is also clear cut irreversible. If the pressure constant 1 atm is there against which you are doing the work, that is called the irreversible process in that case. If someone asks you find the work done, so it's very simple. The work done will be minus P delta V. So understand which P I will put here. Here I will put 1 atm. Some people feel nostalgic about P1. They start treating P1 as their family member. They're like, nahi sir, P1 is going, I feel like crying, sir, P1 is given in the question, I'm not using it. Arey bhai, when P1 was there, the piston was moving kya? Not moving, na? When the P1 was there, piston was not moving. When P1 got removed, then the gas started expanding. So the gas expanded against 1 atm. So against who the work is done? Against 1 atm the work is done. So always when you find the work, find work is equals to minus whichever the pressure is, the external pressure, into delta V. For simplicity, if you want to mug up something, if P1, P2 are given na for expansion, then here you should write P2. So minus P2 delta V. That means the final pressure into delta V you will take for work done. Now this was about the graph in the irreversible case. I think by graph you understood कि we came in other direction and we went by other direction. Clear cut it is not reversible. Now bhaiya, how can I make this reversible? देखो they have beauty, now I will make it reversible. See the beauty here, you will love it. देखो, I take the same brick I take, same mass M is there, but I crush it. And when I crush it, it will become a pile of, we can say, kya? Let us call it sand only. ठीक है? Small granules, powder like situation is there, so sand is there, but pressure exerted by sand is also P1. That means the mass of this brick and the total mass of the sand is same, that is P1, and the external pressure still is P1 plus 1 atm. ठीक है भाई? Out of which the sand is contributing P1 pressure. Let's see what will happen here. Again, here we have ideal gas. Here we have ideal gas again. So understand what I am going to do now in the case of reversible process. How to make this process reversible. तो देखो भैया, understand the idea. I will take one sand particle and I will remove it. Little sand particle is how much? Yeah, negligible mass. I remove it. Negligible increase will happen in the volume. One more sand particle I will remove. Then one more 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 I will remove. Sand particle. One more I will remove. One more I will remove. Then you will get frustrated. Ki sir, do something. 1, 2, 3, 4 particles. If you are removing, then negligible change will come. It will take a lot of time to complete it. Correct? Such kind of process is called quasi-static process. Quasi means false. Static means static. It looks like static, but it is not static because it is a very, very slow process. Time taken is almost infinite time, we can say, or so very long time is taken for completion, for reversible process. Understand the idea, what will happen. देखो भाई, if I plot the graph, whole thing you will understand very easily. देखो, starting from the same initial point here, let's say this pressure initially was P1 plus 1 atm and the volume initially is Vi, same as we started here. But when I remove one sand particle, so देखो when you remove one brick, pressure decreased from this point to this point significantly. There is a significant decrease in the pressure. But when I remove one sand particle, initial pressure was here, then the next pressure will come here. And because of this pressure decrease, volume increase will also be negligible because the pressure decrease is very negligible. What I did, I just made this square, you are able to see na? I just made this square smaller. How? By decreasing this. This is the gap I got created by removing one big mass. Sudden increase in there in the pressure, sudden decrease is there in the pressure. I removed that sudden. So what I did, I made the decrease, but that decrease I made very, very small, almost negligible. Again, I removed the next sand particle, pressure decreased again, because of that volume increased. Again one more sand particle, 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 and so on. If you will see, one by one I am removing these sand particles, you will be able to see something like a curve. Something like a curve getting formed. Okay, bhai sahab? So if you see right now, I am going to zoom in, you can see there is a clear-cut zigzag pattern getting developed. Clear-cut zigzag pattern getting developed. On the other hand, if I want to go up, what will happen? Focus completely. Then I will put the sand particle back. That means reversible. I want to make it reversible. I want to go back. So I put the sand particle back one by one. Still all the sand particles are not removed. 10, 15 only removed. I want to put it back to check if it is reversible or not. So pressure increased, volume decreased because of that. Pressure increased, volume decreased. Pressure increased, volume decreased. Pressure increased, volume decreased, and this way the whole graph will get completed. Now, if you are seeing in the zoom in, you will understand that sir, some dotted things we can see. We can see some small boxes here. Some small kind of boxes we can see here, but these boxes are very small. Now, if I zoom it out, and somehow I am able to zoom it out sufficiently, and I take this somehow camera also back, what you will observe are my chairs in the room, that is secondary, but you will also observe a kind of a straight line or kind of a curvature kind of a line you are able to observe, or we can see a consistent graph you are able to observe. Hai na bhai? So what we can say in the case of reversible process, what I did, same process is there, process is still the same, just that this becomes almost like a curve now, and this becomes a proper reversible process. That means I went in the same direction, I came back in the same direction. Why? Because I created a negligible change in every step. So this happens in infinite steps. Irreversible process. Also one more thing, did you realize that the external pressure is changing continuously? Like initially, let's say the pressure is 1000 gram. I remove one particle, it became 999 gram. I remove one more particle, it became 998 grams. So do we understand that slowly the external pressure is decreasing. So we can say कि भैया constant pressure is not there in the case of reversible process. So if you ever get there is a sudden change in the pressure, it is irreversible. If you see a gradual change in the pressure, ki pressure is decreased from 20 atm to 1 atm gradually decreased, gradually increase or decrease in pressure. If this kind of words you get in the question, 100% apply reversible formula minus 2.303 nRT log V2 by V1 for isothermal you can apply. Also, if you also get expansion against constant pressure, it is irreversible. But if you get कि भैया expansion against a non-constant pressure, something like this is mentioned, a non-constant pressure or ever-changing pressure or consistently decreasing pressure or gradually decreasing pressure. In that case, apply the reversible formula and you'll be through with this. Also, one more thing, we can get a curve in the case of PV curve we can get in the case of reversible process, but for irreversible process, no graph can be plotted. Sir, but you plotted the graph? Nahi yaar, I plotted 2 points only. The point I told you this point and this point are meaningless. They have no meaning of their own. Only this initial point and the final. These 2 points are only there. That means initial point, then after popping when the piston stops, final point. Only these 2 points can be plotted in a graph. So a curve you will not get. You will not get a curve in the PV case. No curve is possible for irreversible. Why? Only some points you will get, and those points cannot be matched because the gas did not come via this path. The gas, you can understand, came via this path. It cannot be plotted like this. So understand the idea. For irreversible, graph cannot be plotted. So if you ever get a graphical question, curves like this are made in the graph. Curves are made like this in the graph. Lines are made like this in the graph. We can understand clear-cut graph. This kind of curves are coming. 100% reversible process. So understand this idea now. Final in nutshell, what to keep in mind. Which is having more work done and which is having less work done. तो देखो, if I remove everything from the board and I plot you a very simple, clear-cut, shortcut idea to remember, तो देखो यार, the situation we understood is this. If this is a PV curve, this is the work done. This is the curve for the reversible as well as irreversible. Reversible expansion as well as compression. Both will follow the same curve. This way expansion, volume increase, expansion. This way compression. Both are there in the same curve for reversible. ठीक है भाई? For irreversible, this is how the expansion will look like, or we can say this is how the expansion will look like. ठीक है? With dotted line I can represent. Initial position, final position. This is how the expansion looks like. This is how the expansion looks like. For compression, it looks like this. ठीक है भैया? For compression, this is reversible compression. This is reversible expansion. So if I say which work done is more, तो देखो idea is very simple. This is the reversible expansion work done. This shaded portion is the reversible expansion work done. Shaded portion number 1. Now, this shaded portion number 2. This is the shaded portion number 2. This area is the shaded portion number 2. I can shade it with the red color. ठीक है भाई? Now, shaded portion number 3, I am making with the dotted. So if I ask you what is the irreversible compression area under the curve, you will say, sir, W irreversible compression under the curve is equals to ... plus, sir, red color shading plus, sir, black color shading. ठीक है? Also, if I say work done, if I ask you work done for irreversible expansion, so you can understand this is the area under the curve for the expansion. Even though we came from here but nothing happened, here only we are getting some area under the curve. So what will be the answer for the work done? Answer will be only the shaded part. And if I ask you work done for reversible expansion or compression, they both will be equal, and that will be equal to this red color shaded area plus this black color shaded area. So what we can happily say कि भैया work done for irreversible compression is more than work done for reversible expansion as well as compression. Same work will be there in magnitude, is more than work done irreversible expansion magnitude. ठीक है भाई साहब? This is from the graph. अब देखो यार, some people will love it from the graph, but some people will love, देखो, I used to love it from the conceptual area. So I will try to explain you conceptually and let's see if you can understand. Two hands, reversible, irreversible. Irreversible has a stone, reversible has sand. Let's compare expansion work. Which expansion work is more? So in the case of irreversible, I remove the brick. The work is done against what? I remove the brick, after that the work is done. So if I remove the brick, only atmospheric pressure is left. So work is done against 1 atm. In the case of reversible expansion, one sand particle removed, second sand particle removed. So some sand particles will be left also, na? So the expansion work or the gas has to push atm plus some sand particles also. So in one case, the gas has to push only 1 atm. In the other case, the gas has to push atm plus sand. So in which case, the more work will be done by the gas? So sir, pushing the sand plus atm is tougher. That is requiring more work. So in the expansion case, reversible work done is more. You can write down this in the notebook. Expansion work, reversible more than irreversible when we compare magnitude. Number 2, irreversible, let us compare. Irreversible means piston is empty, there is nothing kept over the piston. Let's say 1 atm pressure is there, nothing is there, just atmospheric pressure. Now I put one brick here and this push the air down or ideal gas down. Here I put one by one sand particle. So imagine I am the gas here in the case of irreversible. You put one stone of P1 pressure on me, I got pressed completely. Work done on me by P1 plus atm. If I am this piston, you put one sand particle on me, little bit I compressed. One more sand particle you put on me, little bit more I compressed. So yaar, by the time you will put on P1 pressure, that will be the last sand particle. When the last sand particle will come, then you will be able to get P1 pressure over me. Whereas in this second case, you put the P1 pressure from the first day onwards. It is like As soon as the child is born, you put the pressure that this child will become a doctor in the future. NEET exam you have to qualify. Whereas the other child, firstly, कि चलो ठीक है, qualify LKG exam, qualify UKG exam. When he came in the class 11th, then you said ठीक है, you have to prepare for NEET exam. So here the pressure exerted on the candidate is lesser, and here when the person is born, कि नहीं यार, this is the doctor of the family, here the pressure is more, so he will have to do more work. He will be under more pressure. So as soon as a stone is kept from the first second on the piston, whole pressure is exerted on the piston. So what happens? More work done in that case. Whereas when we are having a piston and one by one sand particle you put, the overall work done will come out to be lesser. So in the case of compression, irreversible compression work done is more. You can write down for compression, irreversible work done magnitude is more than reversible work done magnitude. For expansion, opposite. Reversible work done magnitude is more than irreversible work done magnitude. So these were some very big concepts which I tried to concise as much as possible. I don't know how much you might have understood because it's not a live class, it is not a physical class, it's just a recorded lecture. I'm teaching my phone virtually. You might be listening at this point of time. If any confusion is there, pose the doubt, no problem at all. Now, in case your doubt is going to be, sir, what about the NEET 2019 question, work done to negative, positive? Don't worry, whatever I said in this lecture, it does not contradict chemistry. It does not contradict anything which is told by IUPAC or which was given by NEET 2019. I will talk about that question also in my next video when I'll give you some numericals regarding the uses of the first law of thermodynamics. This video was to make your basics clear regarding reversible, irreversible, so that you can fly high in the thermodynamics in the next coming lectures. If I upload 1-2 more, at least maybe tomorrow or day after tomorrow, I will try to at least cover up to the first law. That's all from my side. Thank you so much.